Hi all. So this is the first lecture of Math 202. In Math 202 we will start with motion in space. This is mainly sections 12.1, 12.3 and 15.1. Most of you have done these three sections in Math 201, which describe the motion. So we have, let's say, I have a point P, which is mainly a particle. Point P is moving in space. So it can move in 2 dimension, 3 dimension, or in n dimension, but let's say it's moving in space along a path C during an interval of time t between A and B. So I'm in space, this is in space, this is X, this is Y, this is Z, and now I have the particle P is moving in space, and this is C. So at t equal A, this is the position. So this is the curve C. And at t equal B, this is my last position. And this is where my particle is. So you can imagine this. You have a car driving, you have any motion in space, you have this is the curve, is a one-dimensional thing, but you are moving in R3. So the motion happen in space. Yeah? But the curve is one dimension. This curve C is one dimension. And this is where, which is, I put it in blue, this is my starting point, this is my ending point. Which means at t equal A, this is the position of my point. What does that mean as the position of my point? It is the coordinate of my point. So the position, go back to black. So the position of the particle P at time t can be represented by a vector r of t, which means which is x of t, y of t, z of t. This is the position at time t. So if, let's say, this is at time t, I'm here, this is the vector r of t. This is the vector r of t, which means this is the x, this is x of t, this is my y of t, and this is my z of t. Let's say my particle is moving from point A, this is my initial point, to point B. This means A and B are given. This means R of A, remember, the interval of time is t between A and B. So what is R of A? This will be x of A, y of A, z of A, which is what? X of A, y of A, z of A. Now what is R of B? This is the ending time. This is R of B. This is XB, YB, ZB, which is x of B, y of B, z of B. So what is really R of t? It takes time and it gives me position. So it takes a one variable input, let's say, where it's t is between A and B, and it gives me a vector which has x of t, y of t, z of t. Now, of course, x of t, y of t, z of t now are functions, because this is real, this is real, this is real, and this is a three-dimensional vector. Now we say that R of t is a parameterization of the vector of the curve C. if I know at each time where I am, so I can define my motion. So I know how I move. I can retrace my motion. This is why we say R of t is a parameterization of the curve C. Now what are another way to derive this here, R of t, this is x of t I plus y of t j plus z of t k. So what are x of t, y of t, z of t? These are scalar function representing the I, j, k coordinates of the particle p at time t. At time t. So this makes sense, yes? So at each time I know what is my x, what is my y, what is my z. So I know my position. So first thing we're interested in my position. When a particle is moving, we are interested in what? We are interested in the velocity. So definition. What is the velocity? The velocity vector, very important, it's v of t. Please, something about notation. So when I write in the notes vector, this is because I cannot use the notation of the book or the notation that I will use in the handout or in the question. Usually vectors are represented in the book by bold letter. Okay? But I cannot write bold here, so I just write v vector, v of t. So what does it mean velocity? So the velocity, by definition, is the rate of change of the position. So is the rate of change of the position of p during a time t. When you calculate velocity, let's go back to my motion. This is x, y, z, and let's choose the color. And remember, this is my particle. This is my motion. This is time equal a, this is time equal b, and this is c. Okay, and I need to know what is the velocity. Let's say this is the time t. I need to know the velocity here. So how do I find the velocity? This is r of t. How do I find the velocity here? Remember, the velocity is the rate of change at time t, which means I have to take a small interval. So if this is my position at time t, I see my position at time t plus delta t. So I take r of t plus delta t minus r of t. This is how much I moved at time in an interval of time delta t. So where is r of t delta t? So this is my position at time t. Maybe my position at time delta t is here. So this vector is r of t plus delta t. So what is r of t plus delta t minus r of t? This gives me another color. So this good thing about the iPad, this vector. What is this vector? This vector is r of t plus delta t minus r of t. So this is a motion in an interval delta t. Now this is the rate. I want the rate of change, so I want to divide by the time traveled. So this is the definition of velocity between the time t and the time delta t. How do I find the velocity at time t? I make delta t smaller. So if I make delta t smaller, this vector will become like this, and then become like this. So this vector will become smaller and smaller, and then also delta t will become smaller. So what will be the definition, my v of t will be the limit as delta t goes to 0 of r of t plus delta t minus r of t. But notice that this ratio is the slope of this green line. And notice that what happens, so this is the slope of delta t, this is the slope of this line. And then it's the slope of this line. And then it's the slope of this line. So as delta t goes to 0, what happened to the secant line? It becomes tangent. So very important. So notice that the vector v of t is tangent to the motion at time t, i.e. tangent to the curve C, which in this case is, let me use maybe this color. It is tangent to C. Here v of t is tangent to C. Here v of t is tangent to C. And here v of t tangent to C. It is in the direction of motion because I'm moving from t equal A to t equal B. So maybe this is very important. In the direction of the motion. Okay? And these are the yellow vector. And as you can see, it's not perpendicular to r of t. It's very important. Notice. For example, here, this is my r of t. R and V are in general not orthogonal. V is orthogonal to the motion. It's orthogonal to the path. This is a common mistake that students usually do. Now let's go back. Now this is all physical interpretation. Now let's go back to this. What does this ratio mean? So v of t is the limit as delta t goes to 0. What is r of t plus delta t? This is x of t plus delta t minus x of t, y of t plus delta t minus y of t, z of t plus delta t minus z of t, and the whole thing over delta t. So v of t is equal to the limit as delta t goes to 0 of x of t plus delta t minus x of t over delta t I plus y of t plus delta t minus y of t over delta t j plus z of t plus delta t minus z of t over delta t k, which is nothing but v of t is really x prime of t. This is the definition of the derivative. I plus y prime of t j plus z prime of t k, provided x, y, z are differentiable. So the coordinate of the motion should change in a differentiable way, is differentiable. And this is how I get v of t. So I have r of t is x of t, y of t, z of t. V of t, we write this as the derivative of the vector r, which is x prime of t, y prime of t, z prime of t. Now you know how to calculate velocity vector, but it's very important not to know what it means. It is the rate of change of the position at time t. Graphically, it is tangent to the motion in the direction, it's the tangent to the curve in the direction of motion. And how do I calculate mathematically? I just differentiate. And remember, the velocity is a vector. Now definition, what is the speed? The speed v of t is the magnitude of the velocity vector which means v of t is the modulus of the vector v of t, which is square root of x prime of t squared plus y prime of t squared plus z prime of t squared. And this is nothing but a scalar. Okay, the velocity is a vector, the speed is a scalar. One more definition before we start doing some application. Definition: the acceleration vector a of t is the rate of change of the velocity at time t. Is how much the velocity is changing. Okay, so a of t is the limit as delta t goes to 0 of v of t plus delta t minus v of t over delta t, and this is nothing but dv over dt, which is x second of t, y second of t, z second of t, provided the functions x of t, y of t, z of t are twice differentiable. Now, what does this mean? We saw that the velocity is changing to the vector, it changes the motion. This means how I'm moving, it defines my motion. But what does the acceleration mean? It means something very important, and you know by Newton's law, we have that if a particle is moving, then the force acting to the particle is proportional to the acceleration vector. So the acceleration is in the direction of the force. Since the particle is moving, there's some of forces. Well, it might not have any force. The acceleration might be 0. And if there's a force, the direction of the force can be deduced from the direction of the acceleration. Okay. And this is Newton's law. Here, m is the mass of the particle. Well, let's do some examples now. Examples. I have a particle that is moving along a helical path r of t equal cosine t I plus sine t j plus t k. Okay, and now the question is find v of t, a of t, the speed, and it's question A or question 1 maybe. Question 2, calculate a parametric equation of the line. So this I call line C of the lane tangent to C at t equal pi over 4. Okay. So you can solve this exercise without drawing it, but let's draw it. It's very important. I mean, it's very like you should know what's going on. I mean, I don't want you to just calculate things. I mean, you should care about other things like what's going on, what's this question saying. So what do you know about the path here? So I have here, it's moving such that x of t here is cosine. This is x of t. This is y of t, and this is z of t. Now, do you notice that x squared plus y squared is equal to 1 for all t? Correct? This means that my particle is moving along the cylinder. Well, let's do this in green. This is a cylinder, x squared plus y squared equal to 1. But with increasing the coordinate. So at x equals 0, where I am, at t equals 0, let's say t equals 0, my coordinate is cosine 0 is 1, so it's 1, 0, 0, yes? It's 1, 0, 0, so I'm here. And then as t increase, I'm still on the curve, but I'm still on the cylinder, but my z coordinate will increase. So I'm moving something like this. Sorry, something like this. And this is called the helical path. Okay. So let's see. Okay. Now this is my motion. Now let's calculate R of t. Sorry. I have R of t is cosine t, sine t, t. What is V of t? It is minus sine t. It is why we proved it. This is, well, let's write it. V of t is the rate of change of the position with respect to time, which is minus sine t, the derivative of x, the derivative of y with respect to time. Y here is sine t, so it's cosine t, and 1. Now what is the acceleration vector? It is the derivative of the velocity vector, and this is minus cosine t minus sine t and 0. Now what is the speed? Which is v of t. This is absolute value of the vector v of t, which is square root of minus sine of t squared plus cosine of t squared plus 1. And this is equal to square root of 2. So the speed is constant for each time. And now the question is to calculate the parametric equation of the line tangent to c at t equal pi over 4. Now what do I need to calculate the parametric equation of a line? I need a point. So for a line, I need a point, and then I need a direction vector. So it is the curve tangent to c at t equal pi over 4. So what is my point in this case? My point is r of pi over 4. It is tangent. So since it's tangent with the direction of the motion, I need the slope of this line. And you know that the slope of this line is nothing but the velocity vector. So I know a point, I have the direction vector, and now I can calculate the equation of the line. So what is r of pi over 4? So it's cosine pi over 4, sine pi over 4, and pi over 4. And this is equal 1 over square root of 2, 1 over square root of 2, and pi over 4. So this is somehow here. So if you want to go here, this is this point. Okay? Now I need the velocity vector. Let's check if 3 is this point or, well, yeah, x, y, z is positive. So now what is v of pi over 4? This is the velocity vector. So it is minus sine pi over 4, cosine pi over 4, and 1. And this is minus 1 over square root of 2, 1 over square root of 2, and pi and 1. which you can see it here because this is the velocity vector. It has x that is negative because the x is like this. This is a y, and this is a z. So you see x is negative, y is negative, z is negative. And I want the equation of this line. So I have parametric vectors. So the parametric equation of the line L, so equation, let's see dimension. This is x, y, z. The slope is minus 1 over square root of 2, 1 over square root of 2, 1, times k, times k, times k, plus my point. So plus 1 over square root of 2, plus 1 over square root of 2, plus pi over 4. And this is where k belongs to R. And this is how I find the parametric equation of R. So I will stop now. The lecture is not over, and but I will have to start something different. So I will post it in the next video. So this video cover. Let me see if I forgot anything. This video covers section really 12.1. This is the end of section 12.1.